Today we are going to discuss structures of functional groups. So let's read from the book. In alcohol, the oxygen of OH group is attached to carbon by a sigma bond formed by overlap of sp3 hybridized orbital of carbon and sp3 hybridized orbital of oxygen. Figure 7.1 depicts structural aspects of methanol, phenol and methoxymethane. So here this is alcohol, this is phenol and this is ether. So when you observe the bond angle of carbon, oxygen, hydrogen in methanol, it is 108.9 degree, while in phenol it is 109 degree, and in case of ether it is 111.7 degree. The bond angle carbon, oxygen, hydrogen in alcohol is slightly less than the tetrahedral angle, which is 109 degree 28 minutes. It is due to the repulsion between unshared electron pairs of oxygen. So let's try to understand the meaning of these lines. First of all, I would like to explain the structure of water. So it will recall everything about oxygen. So when you draw the structure of water, here oxygen is bonded to hydrogen by sigma bond and oxygen has two lone pairs. As there are two sigma bonds and plus two lone pairs, the sum is 4. That's why the hybridization will be sp3 hybridization. For sp3, geometry should be tetrahedral. So the geometry of water should be tetrahedral. When you draw tetrahedral geometry, so here this is oxygen. There are two sigma bonds bonded to hydrogen and there is presence of one lone pair and there is another lone pair. Due to presence of these two lone pairs, and you might know very well VSEPR theory. So VSEPR theory means valence shell electron pair repulsion theory. According to VSEPR theory, there is maximum repulsion between lone pair and lone pair, and moderate repulsion between lone pair and bond pair, and there is least repulsion between two bond pairs. So as there are two lone pairs, they repel each other at maximum distance, and these lone pairs repel the bond pairs as well. And these lone pairs pushing away the bond pairs. So because of it, the bond angle 104 degree 28 minutes, which is less than expected bond angle 109 degree. So because of the lone pair repulsion, the bond angle of water is less than, and it is 104 degree 28 minutes. Now come to the alcohol. So alcohol is ROH. In alcohol, oxygen, one side it is bonded to hydrogen and on the other side it is bonded to carbon. And this carbon is bonded to three other groups. They can be carbon or they can be hydrogen. So if I take the example of methanol, this carbon will be bonded to three other hydrogens. So this is the example of methanol. As this carbon has made 4 sigma bonds, means this carbon is sp3 hybridized. And now come to the oxygen. As this oxygen has made 2 sigma bonds and there are 2 lone pairs. So the sum is 4, means this oxygen also sp3 hybridized. And as we have discussed earlier, VSEPR theory. According to VSEPR theory, there is repulsion between lone pairs and lone pairs. So these lone pairs repel each other at maximum distance. And these lone pairs repel the bond pair as well. And because of the repulsion by the lone pairs, the bond angle between carbon, oxygen and hydrogen decreases. And in methanol, the bond angle is 108 degree 90 minutes. And this bond angle is again less than the expected bond angle of tetrahedral, which is 109 degree. Now come to the phenol. In phenol, there is benzene ring, and here it is bonded to oxygen, and this oxygen is bonded to hydrogen. And this oxygen also has two lone pairs. So when you see, this oxygen has made 2 sigma bond and there are 2 lone pairs. So the sum is 4, and for 4 the hybridization is sp3. For sp3 hybridization, bond angle should be 109 degree. But as we discussed in case of alcohol, the bond angle is reduces from 109 degree to 108 degree due to presence of these 2 lone pairs. And according to VSEPR theory, these lone pairs repel each other and these lone pairs also repel the bond pairs. So because of the lone pair repulsion and lone pair bond pair repulsion, the bond angle is expected to less than the 109 degree. But still the bond angle of phenol is approximately 109 degree. So due to presence of these 2 lone pairs, the bond angle of alcohol and phenol should be the same. Means it should also be less than the standard tetrahedral bond angle, which is 109 degree. But still the bond angle in case of phenol is approximately 109 degree, which is the standard bond angle for the sp3 hybridized geometry. So why the repulsion of lone pair doesn't affect the bond angle in phenol? So there is a reason. In case of phenol, the carbon to which oxygen is bonded, this carbon has made 3 sigma bonds. For the formation of 3 sigma bonds, the hybridization is sp2. And sp2 hybridized carbon are more electronegative. They are more electronegative. And being more electronegative, it can resist the repulsion of lone pairs. So that's why the bond angle which is reduced in case of alcohol cannot get reduced in case of phenol. So that's why the bond angle in case of phenol is approximately 109 degree, which is the standard bond angle for the tetrahedral geometry. Now let's read from the book. In phenol, the OH group is attached to sp2 hybridized carbon of an aromatic ring. The carbon-oxygen bond length in phenol is slightly less than that in methanol. So let's see what is the difference in the bond length. So here when you see the bond length, carbon-oxygen bond length, it is 142 picometer in case of methanol, while it is 136 picometer in case of phenol. So why there is decrease in the bond length? Now let's try to understand why there is decrease in the bond length. In case of methanol, so this is CH3OH, this is methanol, and here this is phenol, OH. In case of methanol, there is no resonance. While in case of phenol, there is resonance. So lone pairs of oxygen participate in the resonance of benzene ring. And here you will get another resonating structure of phenol, in which carbon-oxygen bond become double, and this oxygen carries positive charge. It is bonded to hydrogen, and negative charge move to the another carbon. So when you see another resonating structure of phenol, here there is double bond character between carbon-oxygen bond. So due to the presence of partial double bond character, the bond length of carbon-oxygen is less than that of methanol. Now let's read from the book. This is due to the partial double bond character on account of conjugation of unshared pair of electrons of oxygen with the aromatic ring. Second, sp2 hybridized state of carbon to which oxygen is attached. So there are two reasons. In case of methanol, the carbon to which it is bonded, it is sp3 hybridized. While in case of phenol, the carbon to which it is bonded, it is sp2 hybridized. And the another reason, that double bond character. which can be observed in the other resonating structure. So that's why the bond length of carbon-oxygen in phenol is less than that of in methanol. Now come to the ethers. So first read from the book. In ethers, the 4 electron pair, 2 bond pairs and 2 lone pairs of electron on oxygen are arranged approximately in tetrahedral arrangement. The bond angle is slightly greater than that of tetrahedral bond angle due to the repulsive interaction between two bulky R groups. And the bond length, carbon-oxygen bond length is 141, which is almost same as in case of alcohol. So in case of ether, the bond length is same, but the bond angle is more than that of alcohol and as well as phenol. There are two bulky R groups. These two bulky R groups repel each other. And that's why the bond angle is more than the expected bond angle, which is 109 degree.